LeetCode Problem 238, product of array except self. So this problem gives us an integer array called nums, and we have to return an array answer such that answer I is equal to the product of all elements of nums except nums plus nums I. Okay, so basically what this means is, for this index, for instance, the first index of the output, what it wants is 2 times 3 times 4, excluding the first index, right? So 2 times 3 times 4 is 12. 2 times 3 times 4 is 24, so you get 24. For the next index, it will be 1 times 3 times 4, which is 12, so you get 12. So this 8 comes from 1 times 2 times 4, which is 8. And this 6 comes from 3 times 2 times 1, so you get 6. So I only have one approach to this problem, and the approach I used was the prefix and postfix method. So what it means by prefix and postfix is that I gather all of the product before an index and after the index, and I just multiply them together. So for instance, for this index, which should be 8, so I will get 2 times 1, the prefix, and then the postfix, which is 4. So 2 times 4 is 8, right? So I have an example here, using the same example actually. So the prefix would be, actually let's talk about how I start. I have an output. Actually no, let's not talk about how I start, but let's talk about how it actually works first, right? So how does this prefix and postfix actually help to solve this problem? So this prefix, for the first number in the prefix, because usually it is the first number times the number before that, but since there's no number before that, so we use 1. And then the next one would be, so this 1 would then times 1, right? You get 1. And then 1 then times 2, you get 2. And then 2 then times 3, then you get 6. Right, so this 1 could not have existed, right? Because we need something behind it, right? So this is what the prefix looks like, 1, 1, 2, 6. So the postfix, we start from the back, right? So we start from the back, so it starts with 1 on the back. And then we have 4 times 2. Well, actually no, 4 times 1, right? Start from the back, 4 times 1, you get 4. And then 3 times 4, we just make this a line, yeah. So 3 times 4, you get 12. And then last but not least, 12 times 2, you get 24. So this is what our prefix and postfix looks like. And then when we cross multiply, 24 times 1 is 24, 12 times 1 is 12, 2 times 4 is 8, 6 times 1 is 6, so we get the answer in 12, 24, 12, 8, 6, so this is the answer. So this is one way of doing it, by using extra memory to store the prefix and postfix. But we can actually improve it further by using only O1 space complexity. I think, yeah, follow-up question here asks whether we can solve it using O1 extra space complexity. And the tip is that the output array does not count as extra space for space complexity analysis. So what it means that we can actually use the output vector to store the prefix at the start, right? So we store the prefix at the start, and then we calculate the postfix and just multiply them, and then straight away put it inside the output, right? So here's an example of how the code works. So I have an output array, output vector, that I initialize it to the size of num size, which is, in this case, it will be 4, and every number inside it will be 1. So right now our output looks like this, right? Nothing too fancy here. And for I equals 1, so I'm actually starting here. And when I less than max size, so you iterate through the entire list, or the entire vector. So output I would equals to output I minus 1, which is this number, times nums I minus 1, which is this number. So right, so this number would be 1 times 1, which is 1. And then the next number, this, would be I minus 1, so 1 times 2, so it will be 2. And then for this one, it will be 3 times 2, so it will be 6. Right, so this is what the prefix looks like, and if we take a look here, it looks exactly the same, right? So 1126. So after that, we find the postfix, right? So let me just copy the prefix output, and this is what the actual output, the actual final output will look like, just to have some sort of visualization. So we have to use an array, right? Use a variable to store the postfix value. And in this loop, we are actually starting from the back, right? So I equals max size minus 2. Max size is actually num size, which is 4. So 4 minus 2 is 2. So we're actually starting from 0, 1, 2. We're actually starting from this number. And we are iterating to the front of the list, right? So here, postfix time equals num I plus 1. So postfix times equals I plus 1, which is 4, right? Ignore this first, which is 4. So you get 4 times 1 is 4. And then output I, remember this number, times equals the postfix, right? So 4 times 2 is 8, right? So you get number 8 here. So right now we are at this index. So postfix times equals nums I plus 1. So nums I plus 1 is 3. Right, I plus 1 is 3. So 4 times 3 is 12. And then output I times equals to postfix. Right, so this 1 times 12 is 12. We get 12 here. And then on the last, or more like the first index, postfix time equals num I plus 1. So this one, so 12 times 2, which is equals to 24. And then our I would be equals to output I times equals postfix, which is 1 times 24, which is 24. And here you have 24. And here you can see the answer, 24, 12, 86. And then this loop ends and returned the output. That's my solution. That's all I have to show. Thanks.